Hello, everyone. This is Pranav from DFI India. I welcome you all to DFI India Groundwork Webinar 3. Few of the instructions. Recording of this webinar is prohibited. Certificates will be prepared and emailed to you in approximately 2 weeks' time. An online webinar recording will be emailed to you in the same 2 weeks' time. Few of the your control panel details. If you want to see clear screen, you can hide your control panel by clicking on the red arrow. If you want to, if your window, GoToWebinar window is not already maximized, you can maximize it and see it on your full screen. You can always ask a question to the presenters. You go to questions tab, you type your question. Don't forget to put your name and your organization name when you're asking the question. And also we have put few flyers and brochures for you to download. You can go to handouts tab and download the flyers anytime during the program. Now I have the pleasure of welcoming today's session moderator, Mr. T. Rambabu. He is Managing Director of UR Ground Engineering Private Limited. Mr. Rambabu is a consulting geotechnical engineer based out of Hyderabad. He has a experience of 36 years and he has worked on numerous construction and consultancy work both in India and abroad. He has majorly worked on design and build basis projects, especially for shoring system, slope stabilization, underpinning, uplift, arrest, etc. using micropiles, soil nails and rock anchors extensively. He started his professional career as a management trainee in 1983 with EIL. He worked for a year in Canada after his post-graduation there and worked for 10 years in Singapore before moving to India permanently in 2004. He established UR Ground Engineering Private Limited in the same year and offering services in geotechnical field since then. Its branches are in Chennai, Bangalore, and he's also director in Bharat Geosystems Private Limited. So I welcome you, Mr. Ram Babu, and I request you to kindly take over the session and coordinate it. Moderate.
Am I audible? Mr. Jha, am I audible? I'm not able to see.
Yes, sir, you are audible.
Yeah.
We can see you.
Okay, good. Thank you very much, Mr. Jha, for those nice words about me. Namaste to all. Good evening to all those from India. Good afternoon to those from West. And very good morning to those from the far West. A warm welcome on behalf of DFI India to the delegates of today's webinar, Dr. Devon and Mrs. Jules, and to all the participants of today's webinar, students, practicing engineers, fellow professionals, professors, practicing engineers, geotechnical professionals. More important to the students. I once again extend a warm welcome to all the participants on behalf of DFI India. At the outset, I'd like to thank the management of DFI India for giving me an opportunity to moderate this webinar of today's evening. When the chairman of DFI India asked me to moderate this session, I was a bit hesitant at the beginning, but as the subject is very close to my heart, as I use soil nails and anchors in my day-to-day consulting, I readily accepted. So please excuse me if there is any shortcomings in my moderation because it's not a regular affair for me. DFI India, established a little over a decade in India, has been doing a marvelous job in India, getting expertise, experts, and new technologies from all across the world into India to improve the geotechnical profession. I remember very well Dr. K.S. Ramakrishna, who is a senior colleague of mine, an accomplished geotechnical engineer, a very good person, put a lot of hard work in putting together DFI India and to bring it to this stage. His entire team, with the present chairman, Mr. Anirudh Prasad Garu, Dr. Basarkar, and the whole list of professors from premier institutes and professionals in geotechnical field in India are contributing in a big way in furthering geotechnical profession in India. I'm very sure that many people like me got directly benefited with the efforts of DFI India. DFI India has been conducting national conferences, seminars, webinars, and workshops all across India, sharing the knowledge of the experts with the budding engineers. And I was a participant in some of those workshops and seminars. But if I remember right, I never missed any of their conferences, wherein a lot of professionals like me and professors and geotechnical engineers come and share their experience. That 1 or 2 days conference are always an eye-opener for me. I am one of the direct benefactors of that wonderful initiations or wonderful initiatives by DFI India, with very proactive support from DFI headquarters. Anchors are one of the very interesting aspects of geotechnical design, wherein I very big fan of anchors because it gives us an opportunity to test and to validate our design. As we all know, in geotechnical profession, we have a lot of guessing to be done. Though we have a data collected, we guess, we estimate, we presume, we assume, we interpret, we infer a lot of data and arrive at a solution, try to execute it. And during execution, we keep an open mind, saying that change the design based on the response we are getting from the nature. So this design as build approach is hallmark of geotechnical designers, which structural engineers and other professionals may not be able to appreciate, but we need to keep our eyes and ears very close to the nature. Depending on the response from the nature, we need to do that. And in that aspect, anchor gives us the chance to do the testing. See, most of our designs in geotechnical profession are empirical in nature, even today. I can say, though we have advanced on many fronts, pile design even today is empirical in nature to start with. Then we do a load test called initial load test, or few of those initial load tests. Then we go ahead with the design with any corrections if required from the test results. And then we do the routine load test also. So it's a common thing to do that. Similarly, in anchors also, when we install, we test it. And pre-test anchors, we get an opportunity to test each and every anchor. I am a geotechnical professional using anchors and soil nails for last 15 years in India, wherein deep excavations are stabilized temporarily or permanently using soil nails anchors. Soil nails, we have 2 or 3 types which we regularly use in India. One is driven nail, the other one is grouted nail, which is passive in nature, and other one is active nail or active pre-test small capacity anchors to stabilize the slopes. For last 7-8 years, I'm using only pre-stressed anchors because it gives an opportunity to check our design to proceed further. I'd like to share a small case history, or very briefly, I'll just discuss why soil anchors, pre-stressed soil anchors, I prefer. We were doing a project in India, wherein last year, 21 meters of excavation next to an expensive well had to be done. And the project was handed over to us because of one of the villas came down when somebody else was attempting to do the stabilization with some other methods. So we had a setback of 3 meters, and depth of excavation is 21 meters, and approximately in a slope of 1:7, 1:8, we need to do it. The soil was relatively good from 10 meters down, but in the upper few meters, it is a little bit of filled up soil, and then a little firm soil. When we're doing we designed the slope stabilization system and started installing the anchors and pre-stressing them. Was the way the typically a top-down construction where you excavate around 1.5 to 2 meters, stabilize that area with anchors, load the anchors, and then go down. When we reach around 7 to 8 meters depth, a series of anchors in a particular place have failed. They are not able to take the load that we designed for. Then we inquired, when we did some kind of a survey, when we went to the other side, they told us there was a well earlier and it was filled up. So with that, what we could do immediately, we changed our design, I went deeper, and we could come out or went ahead with the project without any kind of a ambiguity or without any kind of a doubt in our mind. Had we used passive anchors, that is the grouted soil nails or driven nails, we would have not been able to detect this well, or in that process we may have compromised on the safety or on the quality of the project. So with that, ground anchors I always rely, and they give us a lot of comfort level when you are doing a project on design and build basis. Also, whenever my structural professionals or structural engineers, they come to me with any tension, I tell them, please give the tension to us, we'll take care of that. Don't worry about the tension, and we execute the project and forget about the tension. So I transfer my tension to the ground anchor and rely on its response and keep going. So with that, very brief words, I would like to go into the agenda of today's program. We start with the introduction of the speaker of today, Dr. Devon, followed up with a technical presentation by Dr. Devon for about 40 minutes, followed up by question and answer session of around 10 minutes. Then the second speaker of the today, Mrs. Jowels, will talk about art of negotiations for next 20 minutes. I'm looking forward for this subject because I'm a very bad negotiator, as most of us we think. And then followed up by 5 minutes of question and answer session, and then we'll have a little bit of announcements and conclude the program. So this is what the thing. With that, I'll introduce Dr. Devon. It's a privilege and honor to introduce a very well accomplished geotechnical engineer of international repute. Dr. Devon Mothersille has compiled around 30 years of experience in consulting and contracting, basically a solution provider in geotechnical profession. He received his Ph.D. from University of Bradford, where from he has actually even graduated also, and is a fellow of Institution of Engineers, a very prestigious recognition. He's also leading 2 specialist companies, GeoServer Global Limited and Single Bore Multiple Anchor Limited, which deliver successfully consultancy services all across the globe in ground anchors and soil nails. He's also an inventor and supplier of ground anchor testing software, Anchor Test. And he was just explaining to me the genesis of this software, how he developed when he was touring in Japan, when his Japanese colleagues or Japanese geotechnical professionals expressed to him, when the entire world is going in digital way with all the robots, everything, the cars, etc., are manufactured without a single hand being put together. So why not geotechnical engineering too? That's how he started thinking and delivered a wonderful software called Anchor Test, which is basically paperless, cloud-based collection of data, dissemination of the data, where you can take the decisions very fast without any bias, without any delay in taking decisions. Dr. Devon has also acted as an expert witness on many legal cases related to ground anchor and soil laying technologies, and is an active member in many committees tasked with the implementation of Eurocode, and is also chairman for ground anchor panel committee in UK. So with that introduction, I request Dr. Devon. We're all looking forward for a wonderful presentation on ground anchors. So I hand it over to Dr. Devon. Thank you very much.
Great. I'm assuming that I can be heard. Okay. Well, I'd like to start off, first of all, by thanking our session moderator, Mr. Rambabu, for a wonderful introduction, and also that little brief insight into that case history that you described in your introduction. Thank you very much for that. I'd also like to extend my thanks to the audience for attending this event here today. So you'll be aware that the subject matter we're going to focus on is ground anchors. Many have argued that because these elements placed in the ground, they are naturally quite complex in nature. And to be fair, it would be almost impossible for me to cover every facet of this technology in the brief time that we have. So that wouldn't be possible. But what I have done is structure the presentation in such a way that regardless of your level of experience, hopefully you'll be able to derive considerable benefit from the session and build on your existing knowledge and improve your fundamental understanding of the subject. So with that, I'd like to move to the first slide. Excellent. Now, my old mentor and professor actually told me, he said, when you're giving a technical presentation, the fundamental rule is you tell the audience what you're going to do, you say what you're going to present, and then you conclude it. And that's a format I'm going to stick to. So today's presentation, we're going to start off by defining what a grouted anchor is. And you notice I've switched the terms there. Instead of ground, using grouted anchor. In essence, they're exactly the same thing. A ground anchor is a grouted anchor. The only thing is that a grouted anchor is a ground anchor that's grouted in the ground, and that will come out during the presentation. So we'll define the terminology and explore the concept to set things up. Then I'll move on to looking at some key applications. And what I've done is tapped into a worldwide database here, looking at projects that I've been associated with personally, as well as what my colleagues have been associated with, to give you a broad perspective on how these geotechnical technologies can actually be applied. We'll then look at design, corrosion protection, we'll look at construction, and we'll look at testing. And within the anchor industry, design, construction, and testing is a sort of the holy trinity of subjects that encompass this subject. But what I've done is included corrosion and corrosion protection in there, because in the majority of cases, we're putting steel inside the ground and we need to protect it from the environment. And it's a very broad-based subject that attracts a lot of controversy, regardless of what region you're dealing with in the world. Having gone through all that, I'll then tie things all up with a case study, which is a raising of Hazelmere Dam in South Africa, which should hopefully bring everything I've discussed into play and consolidate everything and give you a full example of how these systems are applied in practice. And then finally, tie things up with some closing remarks. So that's our setup today. So starting things off, invariably, if you approach someone or the uninformed and talk about the term anchor, the first image that comes into people's minds is the thing that you throw over the side of a boat to stop it floating away. So in other words, to stop the boat floating away, you throw a device which attaches itself to the seabed or to the ground below, and it has a chain or rope connected to it, and that's connected to the boat, and it stabilizes the boat on the seawater. Now, in many ways, a ground anchor acts in a similar way, but instead of stopping a boat floating away on the water, what we're essentially doing with a ground anchor is stabilizing a structure on the surface to stable ground beneath the surface. That's exactly what we're doing. And in certain circumstances, certain applications, we're stabilizing or attaching unstable ground near the surface to more stable ground beneath the surface by using a similar type of technology. So what I've done, I've extracted a figure from the execution code EN 1537, which is a execution code used in Europe. But regardless of where you are in the world, the basic elements of a ground anchor will be the same. And I've just used this as an example. So first of all, I'm going to be mentioning three main aspects of an anchor. First of all, I'm going to be describing the anchor head, which is a part of the anchor that you can actually see. It's attached to the structure. And although in not every scenario you can actually access it, but generally in anchor technology, you can see the anchor head at the surface. I'll then be describing something called the free anchor length. And that's a part of the anchor, which is very important because it transfers loads from the surface through the ground to more stable ground beneath. The important feature of the free anchor length is that it's decoupled from the surrounding grout around it. So all it can do is transfer loads axially and not transversely. So it actually transfers loads from the anchor head through the ground to more stable ground beneath. The third element will be the fixed anchor, and this is a coupled feature. The free anchor length was decoupled, but this is a coupled feature. In other words, it's attached to grout, which applies fixity to the surrounding ground. So if you look at the analogy between with the boat floating on the water, this would be your anchoring mechanism on the seabed. The chain would be the free anchor length, and the attachment to the boat would be the anchor head. And that's how we build the analogy with the boat. So now we're going to really look at the concept. Now, at the lower end of the scale, where you're dealing with small anchors or what we call rock bolts, generally they're about 6 meters long with loads not exceeding 10 tons, 100 kilonewtons. Usually, if you have an excavation in ground, particularly in this example, we have a tunnel, and depending on the way you excavate that tunnel, let's assume you're blasting it through virgin rock. Generally speaking, you'll have a zone of unstable ground around the excavation. And if you drill through that unstable ground into stable ground and place a steel tendon or steel bar through that, grout it at one end, place an anchor head at the other end, and apply a nominal tension, you can invoke a zone of stabilized compressive ground around that opening. And if you do that in a fanned array, then you can create a zone of compression around the whole opening and essentially stabilize it. And that's the lower end of ground anchor technology, small lengths and small loads. As we increase the technology, we go up to the far end where you can have lengths of over 130 meters and working loads in excess of 17,000 kilonewtons. So these are massive systems. And generally speaking, these are applied to dams, where because a dam is a water retaining structure, the philosophy is that the less holes you drill in a water retaining structure, the more benefit you'll derive. So large anchors have been developed for dams for that very reason. And what happens here that when you want to resist overturning forces or sliding forces, you'll drill through the dam into stable rock below, place your anchor tendon in that, grout it in, apply the anchor head, and that will create, and once you apply tension to that, you apply a compressive force to that dam structure and effectively resist the overturning and sliding forces imposed by the restored water. So those are the two ends of the scales, and hopefully in your mind it's illustrated the concept of how anchors actually work. So what I want to move on to now is, as I stated in my introduction, looking at some key applications, projects that I've worked on personally and that I've extracted from colleagues as well. Importantly though, showing you a wide range of applications on a worldwide basis. So we'll start off by looking how things were done back in the day, historically. Propping and shoring was a typical way in which you'd support an excavation. You'd produce an excavation in ground so that excavation doesn't fall in on you. You'd typically shore it using sheet piles or something of that nature, wooden cladding, and then you'd prop it. Now that was effective for many years, but obviously looking at those photographs there, you can see that it doesn't necessarily facilitate the construction cycle because it's very cumbersome. It gets in the way of the movement of plant and is not a very effective way of supporting an excavation. Anchor technology allows us to optimize that whole process. And this is a very interesting slide because it's taken during the construction of Central Station in Hong Kong. And it's an unusual slide because it shows the contrast between using propping and using anchors. In the background of that picture, you're seeing the contractor wasn't able to get the sufficient easements to drill into the adjacent ground. So they had to prop that area of their excavation to support it. In the foreground of the picture, you're seeing an anchored excavation, and clearly the benefits are obvious because the excavation is completely open, you can store plant and material and facilitate the construction cycle a lot better. So it's an unusual slide, but very cleverly illustrates the advantages of both systems. Now, again, here's a very elegant structure. So a water storage tower in Saudi Arabia. The untrained eye would look at that and think, wow, elegant structure. How is that stabilized against the large overturning forces that are resulting from the center of gravity being so high? But the whole stability and structural integrity of that structure is due to the fact that the foundations are anchored. It's anchored foundations, but you can't see the anchors, but the benefits are obvious. Because the center of gravity is so high, that structure can be beautiful and slender and yet fully stabilized because of the benefits of anchoring technology. Moving from Saudi Arabia, now moving to Qatar. And I took this photograph on a site in Qatar where they were carrying out a pile test. Most of us will be used to piles and understand how piles work. Now, it's a requirement that for a percentage of the piles, you have to test them. And this grillage beam is placed on top of the piles, which you can't actually see, and is loaded with concrete blocks. And what would then happen is that you'll monitor the settlement of the piles to show that they're within the criteria specified. But again, looking at this is a very cumbersome process, but historically, this is how things were done. What we're now able to do using anchors is develop this system and optimize it in a far better way. Here you have a pile test carried out as part of the abutment construction for the Wadi Abdoun Bridge in Amman in Jordan. This is a project I was working on. And right there, which I've circled, we have a hydraulic jack there imposing its force on the piles which is beneath the ground, the test pile. But the reaction to that is afforded by this grillage of beams, which are supported by anchors. 16 anchors were installed here supporting these beams, and you're able to load the piles and monitor the settlement of the piles in a far more sophisticated way than what I showed you before with the concrete blocks. The interesting thing about this project, it was a Wadi Abdoun Bridge, a very famous bridge because it was the first double bend suspension bridge in the world. You have many suspension bridges with a bend in them, but this was the first double bend suspension bridge. And I worked on the anchors, the anchored foundations for this project, which were in a seismic zone. So this shows the first bend here and then the second bend, which was constructed in that way for logistical reasons, but a very interesting project. So we're just going through, taking you around the world now, showing you different projects where anchors have been used and which you may not have realized they would have been used in these scenarios. Now, those of you who are interested in rugby would have heard of the Aviva Stadium in Dublin, Ireland. I worked on this project, beautiful structure here, but this kind of glass canopy here acted like a kite. So when wind forces were imposed, the tendency would be for the whole roof structure to float off. So to resist that, anchors were placed in the north and south blades of the Aviva Stadium, and I supervised the whole process of that. So another unusual example where anchors were applied, which laypersons would never actually realize they were applied in that scenario. Not so long ago, a few years back, I worked in a region called Izmir in Turkey for a massive slope stabilization project in an oil refinery, where we use special anchors in the volcanic tuffs to stabilize the slopes. Now, I put this particular example in because a few months ago, this region of Izmir was subject to an earthquake, which was measured at number 7 on the Richter scale. And the anchors were particularly put in place to resist the earthquake loading. And I was very pleased to have the reports come back to me that the slope was not compromised during that earthquake, and the anchors were certainly fit for purpose. So that was very comforting. Another unusual example, we're just going through examples now, just to fix your mind around the way anchors can be actually applied. This is a rockfall protection shelter in Lake Lucerne in Switzerland. The traffic goes along this mountain road here, but without this rock fall protection shelter, rocks would simply fall off onto the cars and cause loss of life. The important thing here is that the whole shelter is a cantilever structure anchored into the mountain. And that way it becomes a very elegant solution for supporting that rockfall shelter. So again, another unusual example. This is a very old slide. It's one of my favorite examples of where anchors have been used, and it's the Oversdorf ski jump in West Germany. This is a schematic of that structure, but the whole foundation of that structure is stabilized because of anchors installed in the base. And again, a very elegant solution. This is how it looks in reality. People have used this ski jump and again would question, how is the whole thing stabilized? But the whole structural integrity is reliant on anchors. Coming towards the end now, just a couple more slides illustrating examples. This is the A2 Autobahn in Austria, and it's the A2 which carries road traffic from Vienna to Graz in Austria. Now, this was subject to a massive slope failure, and the whole thing was stabilized using anchors in this zone here. So large anchors were used, over 100 meters long, to stabilize this structure. We have the thrust blocks here, and you can see the roadway, the A2 on top. And again, we've shown a variety of different applications here, but here's another unusual applications where very large anchors were used in poor ground to stabilize that slope and keep the integrity of that roadway in place. Now, my final slide is probably a slide that none of you would ever have seen. It's a very, very rare photograph. And it actually shows the construction of the Twin Towers, the World Trade Center in New York back in the late 1960s. If you can look to the right-hand side of the photograph, you can actually see anchors there supporting the foundation excavation there. And in the foreground there, you can see reporters showing a lot of faith in the integrity of the anchors standing that close to it. What's interesting here is that the structure here is actually the New York Metro, which was fully excavated and underpinned and kept fully active during the whole excavation and construction process. Now, even by today's standards, that would be very challenging construction. So it's commendable to the engineers and the contractors working on this project that they actually managed to achieve this. But it was one of the early examples of what anchors were used. So that concludes the section and applications, and hopefully it's widened your mind on the vast array of applications that can be used where this technology is concerned. What we will now move on to is looking at some principles in design, and I'm not going to go into a lot of details because we don't have the time, but just show you the basic fundamentals of how anchor technology is designed. Now, there are basically two aspects to the design considerations. The first is that you have to look at the overall stability, and then you have to look at the fixed anchor design. Now, overall stability is all about placing the fixed anchor in sufficiently deep depth that if the structure tries to move, it has to mobilize a cone of rock. So in order to move, the resistance to movement is generated by this notional cone of rock, which obviously increases the deeper you put the anchors. And obviously, if you put anchors adjacent to each other, this conical feature of rock within the ground increases as well. So it's the amount of ground you can mobilize by putting the anchor at a sufficient depth. You also have to ensure that the fixed anchor sticks in the ground itself, has sufficient bond capacity, we call it, or sticking force around that fixed anchor so that it stays in place. So two aspects: overall stability, which is the depth of the free length. So this is placed in deep ground to mobilize in sufficient rock to resist, to create resistance. And then fixed anchor design, which is designed for the length of anchor and diameter of anchor, so that you have sufficient bond stress to give you the sticking force so the fixed anchor stays in place. Now, we're talking to an audience in India, but it's very important that engineers are aware of what is happening around the world. And most of you may be aware that in Europe, most of the geotechnical industry has been taken over now by the Eurocodes. And Eurocode 7 addresses geotechnical design. And this slide, just one slide I'm putting up here, just to make you aware of the approach of Eurocode 7 where geotechnical design of anchors is concerned. So the fundamental basis of the limit state design approach adopted in EC7, Eurocode 7, is that actions, which are the anchor force, this is a term we use, actions, are resisted by internal resistances, which are the steel tendon. So the steel tendon has to resist the action, and also external resistances, which is the bond stress at the ground-grout interface. So the interface between the grout body and the ground is one resistance, and the other resistance is the steel tendon itself. And these are two aspects that have to be taken into consideration when you're looking at resisting the actions, the anchor force itself. So that's all I'm going to say on that, but it's just an exercise in awareness, so you understand the principles of what we're doing here in Europe. So I mentioned before that we are placing steel elements in the ground. There are many types of materials that are used in anchors, and now they're currently developing carbon fibers and that sort of thing. But invariably, steel is used as a primary material for creating the anchor tendon. And because we're placing steel in ground, and we often have design service lives which extend beyond 100 years, it's important that we protect that steel from the surrounding environment. Therefore, corrosion and corrosion protection are very topical issues. So, just very basic introduction to the nature of corrosion. There's basically three types of corrosion that we consider in anchor technology. The first is a generalized attack, where you have a general covering of corrosion on steel. Invariably, that is not necessarily detrimental. In fact, it can be beneficial to creating a good bond with the grout in steel. So one wouldn't necessarily be concerned if you had a general covering of rust on steel. Often if I visit a site and I'm inspecting anchor tendons, I like to see that there's a certain element of rust because it ensures that there's no contamination of grease on that steel, which is detrimental to bond. So a general attack, a general covering is beneficial. What is not beneficial is where you have a localized attack or pitting, small pits in localized areas along that steel. That is highly detrimental and can create early failures in anchors. So that wouldn't be desirable. The third mechanism is what we call stress corrosion cracking, or environmentally assisted stress corrosion cracking. And this is a more complex mechanism, which is based on the hydrogen content in the steel, which makes it more brittle. And what we find is that high tensile steels are more susceptible to this mode of corrosion. So you have generalized attack, localized attack, and stress corrosion cracking are the three primary modes of corrosion that we consider in anchor technology. Now, what you're seeing here is an unprotected steel tendon in a Victorian soil retention system with no protection at all. And clearly, when you're looking at that, you can see there's very little in the way of tensile capacity left in that element, and that's highly undesirable. And to avoid that situation, this is why we look to protect our tendons when they're in the ground. So how do we do that? This is a slide taken from BS 8281 2015, which is a code of practice, a standard governed in the UK for anchor technology. There are many different practices around the world, but I've used this as an example because it tends to be the most rigorous that's actually applied. And invariably, what comes up is the concept of double corrosion protection, where in the UK, what is required are two physical barriers to protect the steel tendon from the surrounding environment. So that in the free length, what you have is polypropylene sheaths, one sheath and a second sheath around the steel tendon to protect it from corrosion and the surrounding environment. And then in the fixed length, we have polypropylene tubes or ducts in the fixed length. Two barriers, two physical barriers protecting the steel from the outside environment. So there's no reliance on the grout to do that. Now, cement grout is alkaline in nature, and certainly it has a pacifying effect where corrosion is concerned. But because it cracks, it's not relied upon as a primary protective means. Physical barriers are required in UK practice. Now, I mentioned the Wadi Al-Dun Bridge in Jordan, and I showed you that double Brent suspension bridge in an earlier slide. And what happened there is that the client specified that the anchors needed to be double corrosion protected, but they wanted me to demonstrate how that mechanism of protection worked. And obviously, once you put it in the ground, you're blind because you can't see it there. So what I did, I created what we call a grout simulation, where I created a plastic tube the same diameter as a borehole, and installed a test anchor inside it, grouted it in, and once the grout cured, cut it in sections to demonstrate to the client how double corrosion protection actually works. So in the free length section, you're seeing the first barrier to protection, as the arrow indicates, and then you're seeing the second barrier to protection, the sheathing around the strands themselves. Now this sheathing is, the strand is surrounded in grease or corrosion inhibiting compound, and then the sheathing, so it can slide axially up and down without transferring load transversely. And this is what we call, I mentioned it earlier, decoupled effect. So essentially you have two barriers there. In the fixed anchor, clearly we have the first barrier here and then the second barrier, double corrosion protection, first barrier, second barrier. The strands here, clearly there's no sheathing around them because they're connected to the grout. They have to be connected to the grout because they have to transfer load and give us a fixity we want in the ground. But clearly what you have here is two barriers, both in the fixed anchor and the free anchor length, which is the definition of double corrosion protection. What I then did is remove the tendon completely and cut the whole simulation longitudinally. So what you're seeing here is the first barrier, corrugated duct, plastic duct, and then the second barrier, and then the outer barrier here is, well, the outer tube is a borehole. So it's a simulation showing you how double corrosion protection actually works, giving you two physical barriers. So that's enough on design and corrosion. What we'll now move on to is construction. So we're going through the main elements of what constitutes this technology and implements it in the field. So construction. What I've done here is really look at illustrate the four basic aspects of grouted anchor construction. First of all, you'll drill a borehole. Secondly, you'll install the tendon in the borehole. You'll then grout the tendon in the borehole. And then final stage of it, you'll apply a pre-stress to the anchor assembly. Those are the four basic elements. Where drilling is concerned, all I'm going to do is really put up a few slides here, just showing you, if you're not familiar with this technology, how it actually looks in the field. These are basic anchor projects, stabilizing excavations where we're drilling the anchors in using these drilling rigs. Here we have an auger here going into alluvial deposits. And often when you're adjacent to water and you're installing anchors to support wharf walls, you can attach a drilling mechanism to a construction plant like that and drill back on yourself. So that's a good example of how you can work when you're working above water, and it saves you going on the water with barges, drilling in from that end. So it's a very convenient way of doing it. So it gives you a feel of how drilling looks in reality on a construction anchor site. Installation of anchors, sometimes we have to use operatives to carry the anchors into place. We use cranes. If the anchors are very, very big, we have to use these trailers with tractors to drag them along. And they're very, very different means of installing anchors. And often in remote sites, we even have to use helicopters to get those anchor tendons in place. And this is a helicopter installing an anchor tendon on a dam. So again, a few pictures just flashed up to give you an indication or a feel for how this looks in reality on site. Having installed it, you have to grout the anchor. And this little cartoon is really tongue-in-cheek, but it really serves to illustrate an important point, that when you're applying grout within the ground, you have to have a feel for where the grout is going. And it's very, very important because it can cause a lot of disruption, and also a very expensive part of the process if you're just pouring grout in the ground without understanding the quantities on exactly where it's going. If you're dealing with poor ground like this, it wouldn't be sensible to simply drill a borehole, put your anchor tender in and start grouting it. But clearly, because the ground is so permeable, the grout would simply just run away into the ground and it wouldn't give you the mechanical bond that you actually need. So the important point here is that when you're encountering poor ground with anchors, the idea would be to create your borehole and pre-treat that ground by pre-grouting it first of all. You'll then re-drill it, place your tendon in place, having water tested to make sure that it's grout tight. You then place your primary grout. So the important point here, when encountering poor ground, you pre-treat the ground first so you can get adequate primary grout to stay in place. The final stage is stressing and testing. And generally speaking, we do this using hydraulic jacks because we want to apply a pre-stress force to the anchor to give it that restraining force to the structure. So here you have the anchors inside the structure. You have a mortar pad here, and then a hydraulic stressing jack and various instrumentation to measure the load loss using load cells or creep using dial gauges. So you'll monitor the behavior of the anchor in terms of its ability to retain its load or its ability to creep within specified limits. How this looks in reality is this, like this, where you have the hydraulic stressing jack here, the anchor tendons, which are pre-stressing strands coming out here. You can use single bars as anchors, but in this example, it's strands, pre-stressing strand. And you see a dial gauge here measuring the displacement of that jack, which is giving you a load extension characteristics of that anchor. The philosophy in testing, no matter where you are in the world, is always the same. You generally impose a load on the anchor greater than that which is required of it in service. So greater than its working load. That's called the proof load. You hold it at the proof load for a certain period of time, and you monitor its ability to retain its load or its creep characteristics. And having done that, if it's within certain limits, then the anchor can be deemed satisfactory. And this is an extract from the latest European testing code. It's an International Standards Organization document, 22477 Part 5, issued in 2018. And it shows, and it's the primary code used in Europe. There are basically 3 test methods, and this slide is showing the first test method, which is used in the UK. Obviously, I've had to go through this very quickly, but for those of you who are interested, Ground Engineering Magazine, December 2018, I produced a technical note covering all the basics of anchor testing and the philosophy behind the new testing code that was published in 2018. So for those of you who are interested, Ground Engineering Magazine, December 2018 edition has a full article on that. So our section moderator, Mr. Rambabu, commented on the fact that we created a special tool to facilitate the testing process, and this is called Anchor Test. And I'm mentioning it now because it's a contemporary technology that is really at the forefront of anchor technology right now. So there isn't another product like it. Essentially, what we found is that using laptops on site and that sort of thing are very cumbersome, and they're not really suited to the rigors of a dirty site environment. So we created a tool on an iPad, which allows us to optimize the whole analysis and data processing aspects of anchor testing in real time. Anchor testing is a mandatory process, but it can be very, very time consuming, create a lot of data. And often when that data is created, people usually put it into Excel spreadsheets. It's then analyzed and then compared with certain criteria, which it has to pass before you get the go-ahead to go to the next level of excavation and anchor installations. And this process can be very time-consuming. I've experienced this personally. By the time we get the go-ahead to move ahead, time has gone and the program is slipping. So what we find is the tool we've created in Anchor Test takes away that process, and it gives you a paperless solution which allows you to process the data, assess the anchor in real time, so you can give decisions immediately on how the anchor is behaving. And so basically what you've got here is a couple of screenshots really illustrating how the iPad looks in reality, where we can analyze the load extension behavior of the anchor, assess it with the criteria specified in the standards, and give a decision immediately on whether the anchor is fit for purpose. That way you can move on to the next installation. It's a cloud-based solution, so all the information is on the cloud. So any nominated expert can view that information and give us feedback to the site in real time. So it's proved to be a very, very useful tool in anchor technology used worldwide. And I wanted to introduce that to you. So the benefits of being a cloud-based solution is that it makes things work in a lot quicker, in a much faster way. The process is analyzed, the data is stored, and assessments are made in real time. So please be aware of that. So having gone through all those basic processes, we looked at applications, we looked at design, construction, testing, and corrosion protection. We looked at anchor test. What I want to do now is bring everything together in the final part of the presentation to show you how all these aspects are implemented on a real site. And this is a very, very special site because it was a project in South Africa where they decided to raise a dam by an unprecedented 7 meters. So, basic background. During my last tour of duty, when I was coming back from the project, because I was lead engineer on this, I was on the BA flight 6200, and I simply looked out to the window. We happened to be flying over the dam. And so I put my iPhone against the window and took a photograph, and you can see the tower crane here. Here are the site huts on the right-hand side, and here's the concrete gravity dam. So I thought it was a very useful picture to start things off with, because that's showing an aerial view of Hazelmere Dam, which will be very unusual. The Hazelmere Dam is situated on the east coast of South Africa, near a place called Devon. Very beautiful part of the world. The dam is located on the Mshloti River in the KwaZulu-Natal region of South Africa, about 5 kilometers from the town of Verulam. It's a conventional concrete gravity dam built in 1976 for water supply purposes, but importantly, it was founded on quartzitic sandstone. The other main features you should be aware of is that the dam was 48 meters high, 478 meters long, but importantly, the full supply level was going to be raised by 7 meters. So in other words, to give increased water supply, they had to raise the height of that dam. By doing that, you had to have a means of stabilizing that dam. And prior to using anchor technology, the South Africans were simply going to use mass concrete, create the massive gravity footprint of that dam to actually execute this solution. But this wouldn't be an environmentally acceptable solution. So when we introduced anchor technology, it was seen to be far more optimal in creating the stability needed. So there are 3 key aspects of this construction. The first is the restoration of the grout curtain. Now, what does that mean? If you have a concrete gravity dam, you're storing water, there's a tendency for the water to seep underneath the dam. And that could create uplift problems, stability issues, and so that needs to be addressed. The way the original contractor addressed this issue is by creating a grout curtain. In other words, a wall of grout beneath the dam, which intercepts the flow path of that water from the reservoir and keeps the dam stable. But tests showed that this grout curtain was being compromised over time, so they had to restore the grout curtain. And that was the first aspect of construction. The second aspect of the construction was creation of what we call a piano keyway, and that's this unusual looking structure in the spillway of the dam. What it essentially does, it increases the hydraulic length of the spillway by a factor of 6 by creating these zigzag, this sort of piano key configuration. And because they had to dig down 3 meters to create this structure, and we're increasing the dam by 7 meters, a 10-meter piano keyway happened to be the largest PKW in the world. So again, a key feature of construction. The third feature, which is what I'm going to focus the talk on, is the fact that we had to use anchors to stabilize the dam. Essentially, 83 anchors were used, but what's important is that the test loads of these anchors went up to in excess of 19,000 kilonewtons. That's over 4,200 kips. The boreholes were 355 millimeters in diameter, and the overall length of the anchors were 90 meters. And it was constructed using the specification BS 8081 1989, the British Standard Code of Practice for ground anchorages. So Very unusual, and it so happens that this happened to be the largest capacity cyclically loaded anchor systems in the world when it was actually constructed. So when you're dealing with a project of this nature, it's very important to mitigate failures. You have to carry out a substantial test anchor program. And we essentially executed the largest sacrificial test anchor program in the world when we actually did this. Here's a view of the dam with the spillway deconstructed, completely demolished there in preparation for the construction of Keyway. But the blue arrows indicate the positions of the trial anchors that were put in place sacrificially so we can test them to failure to look at the geotechnical capacity of the ground. The red arrow illustrates the position of what we call a dress rehearsal anchor. And this is an anchor installed in the crest of the dam so that the contractor could demonstrate their ability to execute an anchor under these conditions. This is highly specialist work, and even though the contractor had a very strong CV, they hadn't worked in South Africa before. So I stipulated that I wanted them to carry out these test anchor programs so they could demonstrate their abilities to execute the work effectively. The anchors happened to be, at the time, the largest sacrificial anchors in the world. There were 61 pre-stressing strands in each test anchor. I showed you an early slide in the Wadi of Doom Dam where we had a test anchor with 7 strands in them. These are 61 strands. And in fact, in the total capacity and the highest capacity anchors went up to 91 strands in this particular dam. So you're talking about very high capacity systems, and really you're pushing anchor technology to its absolute limits. A few photographs now just showing you the drilling of the test anchors in the Stilling Basin. This is the downstream end of the dam. It was logistically favorable that we constructed the stressing blocks off-site and constructed the anchors as a separate exercise. So the anchors were fully constructed first. The thrust blocks were then taken, craned in place and placed on top of the anchor. And this is because we're using large punching loads and we don't want that load to punch into the ground. So you need some sort of reaction block. And these are the placements of the reaction blocks. Here's a slide showing the placement of the anchor tendon itself using a crane here. You can see the buggies bringing the anchor along. It's then lifted off and placed inside the borehole. These are typically 40 meters long. But importantly, they place the fixed anchor in the location where the production fixed anchors would be placed on when the anchor were actually constructed for the full dam. Now, we constructed, as I mentioned, a dress rehearsal anchor, and here you see this being wheeled along. Because it's 61 strands here, these are very heavy systems, so you can't manhandle these at all. So they have to be taken in by crane. And I put a little circle here which illustrates me on the crest of that dam supervising this whole process. So very challenging work, but very, very gratifying in what we actually achieved in this project. Once again, this is the stressing of the test anchors and the use of anchor tests to give us a real-time indication of how the anchors are behaving and showing that they were fit for purpose. We took the test anchors to failure, so we wanted to find out the geotechnical capacity of the ground. So we deliberately tried to fail them. It so happens at the time that the rock was sufficiently strong that we couldn't generate failure, but we got maximum test loads, and we were able to use that data to facilitate and optimize our design of the production anchors. The corrosion protection system used was very substantial, and it involved using polypropylene ducts. I mentioned corrosion protection, double corrosion protection in a previous slide, but it's important to point out here that the code of practice allows double corrosion protection or single protection. Now here, you can use single protection providing you prove the integrity of that protective barrier in situ. So we installed, what that means in reality is that we installed a single barrier into the ground. We tested it in situ by using a water test to show that it had its full integrity. And once that was proven, we're able to use that as a protective barrier. If you're not carrying out that process, you have to use double protection, which are 2 physical barriers, which means that the outer barrier is essentially sacrificial. because you only need one barrier intact to protect the anchor. So we know that from experience that the anchor head is one of the critical locations where corrosion can actually occur. So once the anchor head is actually put in place, a special wax is injected beneath the anchor head so that it fills the void beneath it, which is vulnerable to corrosion. We then place a special sleeve around the anchors and corrosion inhibiting tape, and then fill that with a wax compound. Once the whole thing goes off, the whole thing is then covered in a galvanized cap. What this allows us to do is that in any future day, if we need to inspect the anchors, we can take the caps off, remove the grease, inspect it, analyze it, check it for loads, and replace the whole thing, reinstate it afterwards. So this is what was required in the contract itself. So stressing and testing. In order to stress these anchors, we actually had to commission the construction of the largest hydraulic stressing jacks used for anchors. These had a capacity of 22 meganewtons, 22,000 kilonewton capacity. I'm 5'10" tall. This gentleman next to me is about 6'2". So you can see when the whole thing is extended, the size of these systems, they're absolutely massive, weighing approximately 10 tons in weight. So they had to be handled very, very carefully to put in place, but we needed that kind of capacity to generate the loads, the working loads required in this structure. Here's a photograph of me stressing and looking at the using anchor test to analyze the data on an 80-strand anchor in the spillway of the tunnel of the dam. Now, back in May 2017, just want to show you a picture of how the structure looked back then. Here we have the spillway, the PKW, during its construction. We have drilling rigs for the anchors put in place, and this is in May 2017. Importantly, at that time, the water level had increased so that the full supply level was 120% of its original level. So already, even without all the anchors in place, the structure is already being tested. So it's it was a critical stage, and the whole dam was monitored for movement to show that its full structural integrity was fully in place. Just while we go from May to November 2017 now, the PKW is well underway now. Many of those units are fully constructed and many of the anchors actually put in place. Just giving you a visual impression of how the project actually looks through time. And then we go to February 2019, where the PKW is fully constructed now. And out of the 83 anchors, 73 of them are fully constructed. Now, interestingly in this project, the project is still ongoing because for non-engineering reasons, the project had to be stopped at a certain point in time for a period of 3 years. We have to go back there, and I'm now commissioned to go back there late in a few months' time to complete the final instrumentation of the final 10 anchors to make up the 83. So 73 are in place, 10 remaining, and they're going to be fully instrumented with load cells and that sort of thing. So once again, obviously I've had to go through that fairly quickly, but for those of you who are interested, in the September and October 2018 edition of Deep Foundations magazine, produced an article called Dam Anchoring Fundamentals. In the November-December edition, part 2 of that article came out, and that describes a lot of the elements of this particular case history. So it gives you a further insight into the project. So some closing remarks just to finish things off. Essentially, we started off by defining what a grouted anchor was, described and illustrated the various applications with examples drawn from a worldwide database of projects. And hopefully that gave you a feel for how anchor technology is applied on a variety of different projects, from deep excavations to holding down water towers to supporting dams, etc. We then went on to look at the fundamentals of anchor design, including corrosion protection and corrosion, construction, and the mandatory testing process. Those are the basic elements which form the anchor, and hopefully it gives you a feel for how the basic elements are put in place to get this implementation of the technology in practice. Finally, we then looked at a case study which described the raising of Hazlemere Dam. And it's very, you know, it's not often you get a situation in engineering practice where you have a number of world firsts put in place, but we had that on this project. One of them being, we implemented the world's largest capacity cyclically loaded anchors. We also instigated the largest capacity hydraulic stressing jack equipment for pre-stressing anchors. We constructed the largest P&O keyway. The largest sacrificial test anchor program was put in place, and it was the first use of the software anchor test on a dam project for the management and storage of data in real time. So all these elements made the project very, very interesting. And once we complete the exercise, no doubt further papers and everything will come out once we instrument it and look at the behavior of this structure through its design service life. So with that, I'd like to thank you for your attention and hand you back to our session moderator. Thank you.
Well, thank you very much, Dr. Devon. As expected, it was wonderful, wonderful, wonderful. You gave a wonderful overview of a variety of projects across the continents. And then you introduced very nicely the basic, very basic concepts of designs with a little importance to the corrosion protection. And the capping of the whole thing is fantastic case history of dam raising by around 7 meters of Hazlemere Dam near Devon in South Africa. Everything associated with that project is all large. So nice to know the largest equipment that you developed for stressing, which can stress up to 2,200 tons. It is one of the very biggest things. We use 1/100th of that in most of our projects. So, and the height of that compared to the tall man, still the tall man appears to be short in that in front of that. That's a wonderful thing. And the largest PKW that you could put in place. And you installed already 73 anchors out of 83. And it's mind-boggling to know 80 strands, 90 strands. And finally, when you try to test an anchor to its failure, it refused to fail. That's wonderful. So finally, you had to give up saying that. And I would like to ask you one question. What was the ultimate skin friction that you could get before it refused to fail?
Right. Yeah. Well, the test. Excellent question. From memory, the 1,350 kilopascal was the friction generated in that particular project. The important thing here is that what governs the skin friction in these scenarios is the rock mass itself, not just the intact strength of the rock. And often empirical studies say that you can use 10% of the intact strength to give you an indication of the skin friction you can generate. That's not, although that's very broad based, because obviously the discontinuities in the rock mass determine ultimately how the whole thing behaves. And because we had fixed lengths up to 9 meters long, it's a big distance where a lot of discontinuities come in place. So that was the working skin friction that we generated, and we use that to optimize our designs.
Very good. I have a few questions some of the people are asking. I'll start with a very simple question from Minu Joy from Cochin University of Science and Technology. Her question is on, I'm trying to see. Her question was basically, I'm not able to locate over here right now, but whether anchors can be used like soil nails. I obviously answered yes, but she would like to know from you also. And along with that, I have some more questions. I'll take one by one. Yeah,
right.
Thank you.
Well, yeah. I mean, it's an excellent question because there's a fundamental difference between anchors and soil nails. Soil nails are regarded as a reinforcement, a soil reinforcement measure, a ground reinforcement measure, because they act passively. And they're essentially fully bonded along the entire length. There's no free length in a soil nail. So its tensile capacity is mobilized by movement of the surrounding soil. So it acts as a reinforcement type element. Anchors are regarded generally as a structural element, where they're not bonded along their full length. They have a free length. So the essential mode of behavior is to transfer load from one point to another, whereas a soil nail acts along its entire length. So yes, they can be used, both mechanisms can be used to stabilize ground, but they work in different ways, and it's important that that distinction is made. Soil nails are passive elements, so their tensile strength is mobilized by movement of the structure, whereas anchors are active elements where we impose loads on the anchor, which then adds restraint to the structure. So two different mechanisms, but they can be both used to support ground.
Perfect. Yeah. One is pre-stressed, and with that you are able to generate the stresses in advance, whereas the other one comes into action when there is a movement in the soil. But sometimes it will be too late. They start moving, and if there's any inadequacy in either execution or inadequacy in the design or any other things, they'll be a little bit difficult for us to control that. So I prefer personally to go with the pre-stressed anchors. The next question is from Mohammed Sahid Khalid from Dubai. And he is with a company called MEFG. And his question is, please explain the requirement of clause 6323 of BSEN 1537-2013 that deals with unforeseen extended service life, whereby to increase the design life to temporary anchors beyond 2 years. So that is the question. You can.
So yeah, I haven't got the clause referred to in front of me, but you're talking about an action to extend a design life beyond 2 years of a temporary anchor. Is that, am I understanding that correctly?
Right. His question is basically unforeseen extended service life, whereby to increase the design life to temporary anchors beyond 2 years, if you want. So there is some clause probably which tells about how to extend the design life.
So if you so often we have scenarios where anchors are installed, temporary anchors are installed for various reasons beyond which were unforeseen. The design service life has been extended. So in other words, if the design service life originally was 18 months up to 2 years, if it's extended beyond 2 years, what do you do with those temporary anchors? That's the issue. Now, because they're obviously installed in the ground, it's very difficult to do things remedially to affect the anchor within the ground because it's already installed. But what we do in circumstances like that is that we monitor the anchors and inspect them first of all. So the first protocol is that you inspect them to see what state of corrosive degradation has taken place. Then, depending on what you find, decisions are then made. Now, you can remediate anchors. There are techniques to remediate anchors if you want to increase service life, because we know that the anchor head is the most critical part of the whole component, the accessible part. So you can remediate anchor heads to increase service life, but it's often a very expensive exercise. So the technique used is to inspect, monitor the structure to make sure that there's no untoward movements, and by inspection and monitoring, you can then make a judgment as to how the anchors are performing. Providing the conditions aren't aggressive, then often you might find that temporary anchors can last a lot longer than the 2 years they're specified for. But if the conditions are aggressive, that you have sulfides and chlorides within the groundwater, then they can actually corrode very, very quickly. And in circumstances like that, as I say, the key is inspection and monitoring. That's how we approach that.
Yeah, we have to keep a constant tab on the monitoring, and then get the data and keep checking it. So that's how the nature is responding. We have to keep a continuous tab on that. Yeah. I have another question from Mr. Mohan Ramanathan, who is an active member in DFI India. His question is congratulated for an excellent presentation from your side. And then his question is on, you tried to test the sacrificial anchor to failure, but you could not. In that case, when you install and stress the working anchor, what reserve capacity you thought you had? Did you provide for the fatigue and creep and the unknowns from the rock itself? Your opinion. That's from Mohan.
Right. Excellent question. Yes. Okay. First of all, we installed the test anchors, and based on the geotechnical parameters, we gave an estimate of what we believed the failure load would be. We then put in sufficient strand, anticipating that failure, we would be able to geotechnically fail the ground. It so happened that, as I've explained, the ground was a lot stronger than anticipated. So rather than getting a failure load and applying a factor of safety to a failure load, what you effectively get is a maximum test load. And you apply your factors of safety to a maximum test load. But that means that there's a contingency built in, because we know there's more capacity left in the anchor, in the ground itself. We then, having applied our factors of safety to the maximum test load, we then use that in the production anchor design. And then we take it from there. Now, BSA 281 allows us to look at the creep of the anchor, and it has special provisions and criteria that the anchor has to satisfy. So once we put that in place, we're able to monitor those anchors very rigorously to check the creep and load loss criteria to make sure that throughout the design service life, the anchor will be fit for purpose. But it's an excellent question. Often you want to get a failure load, but you can't always achieve it if the ground decides it's not going to give it up. So that's a ground can be surprising that way, but it's a good problem to have. It's a good problem to have ground that is stronger than you anticipate, which is great.
Yeah, all we geotechnicians would like to have that kind of ground which can offer us such a relief, especially in some cases. I'm dealing with one case where it's highly plastic clay, and it is giving me a hell of a problem. Anyway, there are a lot more questions actually, but I think we are running out of time, and I request we will definitely send all these questions to Dr. Davin, and he will definitely answer. And it's the number of questions does indicate, Dr. Devon, that it was a wonderful presentation where it has generated a lot of interest among all the geotechnicians. I call them geotechnicians because we're all geotechnicians. And what we'll do is we'll put together all the questions and send it across.
Please do.
And I assure all those people who raise the questions that you'll get a right answer. And those people who could not put the question right now, you can also put in mail to DFI India, so that we'll assign to Dr. Devon and we'll get the reply to you. Thank you very much, Dr. Devon.
All your questions will be answered.
Yeah. Great. Thanks a lot for that wonderful presentation and enlightening and enticing presentation. We are very, very thankful to having shared your knowledge with the largest anchor projects in the world, which is still taking, which we're completing very soon. So thank you very much, Dr. Devon, for sparing your time. I'm very sure that your time is very, very, very precious, but you did spare that wonderful time for us to share your knowledge and expertise with our engineers in India. Thanks a lot, especially the students. Mostly 60 to 70% of these participants are students, and 20% from the academics, and 20% from the professionals like me. So thanks a lot, sir, once again for that wonderful presentation. And with that, we move on to the second session. We'll pass on all the questions to you later. Yeah, thank you. Thank you very much. Mr. John? Yeah, now we move on to the second part of the session where I would like to introduce Mrs. Jules Stover, who is a project manager for major projects in a very big company called Nicholson Construction from Colorado. Very good morning, madam.
Good morning.
Thanks a lot for getting up early. I'm sure it must be around 5:30, 6 o'clock in the morning, and a hot coffee must be keeping you awake. You know? Thanks a lot. Thanks a lot for getting up early and to share your experience on a very tough subject, which is art of negotiation, which is I'm very bad at it, and most of us are very bad with geotechnical engineers. And with that, I'll introduce Mrs. Jules. She is a project manager for major project division in Nicholson Construction, building complex projects, and her career in geotechnical construction industry since 2007. She has been excels in the problem solving, building strong relations with the clients, facilitating positive outcomes on even the most challenging geotechnical projects. She is very passionate about diaphragm walls. Her team has recently completed both largest known diaphragm wall and smallest possible in the world. So that shows the range of projects in which you're working, from the very small diameter to the largest diameters. And in diaphragm wall, I'm a little bit intrigued between the diameter associated with the diaphragm wall. Diaphragm wall is generally a linear element. So diameter with diaphragm wall. So anyway, I'm a little confused on that, but you can clarify later. But we are looking forward to enrich ourselves in art of negotiations so that we can be a better negotiator. Thank you, madam, for your time. And it's all yours now. You please go ahead with your presentation. Thank you.
Thank you very much, Mr. Rambabu. And thanks to Dr. Devon, that presentation on ground anchors was awesome. Very, very well done. I'm glad that I got to sit in on that before I get to now talk to you guys about the art of negotiation. So while I am a construction professional, today we're going to focus on a little bit more of a professional development topic, one that seems to be a very hot button one for a lot of people. A lot of, I'm not good at that, and ooh, you know, I don't really like negotiating. It's tough, it's hard. So we're going to take a look today a little bit about how we feel about this topic of negotiation, especially when it comes to the workplace and our business, and maybe some techniques and skill sets that we can hopefully start to be better at negotiation. So let's see if I can, oops. So we'll start with the basics. What is negotiation? Negotiation is a discussion aimed at reaching an agreement or a method by which individuals settle differences. So where do we negotiate? Many people immediately think of that scenario in which we are asking for a raise or negotiating salary when taking a new job, or perhaps negotiating your fee proposal on a large contract your consultant firm just won, or a potential issue in the field. But the truth is, everything in life is a negotiation, and we can sharpen our skills for these tough workplace situations in our everyday lives. How about negotiating the purchase price of a new vehicle, or trying to get the family to agree on what this year's vacation will be, or how about dinner tonight? What will that be? That can always be a negotiated topic. So we negotiate with our significant others and spouses, our friends, children, the general public when we are consumers. And of course, there are those conversations that we all dread and where we have to pull out all of our skills to ask for that raise. So when I first started doing some research for a presentation I gave on negotiation skills for DFI in the United States, I got to put out a survey to one of our committees, and we're actually going to re-release the survey to more of the technical committees and get some further data. But I was interested in, do people like this? Do we think we're good at it? So we got to send out a survey and collect some data. And basically the first question is, do you like to negotiate? And you can see here it's close to 50-50, but more people are kind of on the side of no, don't really like that. We feel like it's hard, you know, we're not very good with this perceived conflict or confrontation. It makes us very uncomfortable, especially when the stakes are high. You know, or if it involves higher level personnel, you have to sit in front of CEOs of potentially your clients, stuff like that. That sometimes we defer to higher levels within our company. Oh, that's not for me. Somebody more experienced or has more authority should take that on rather than I do. Or these feelings, I'm just not good at it. You know, I don't get the opportunity to do it a lot, so I don't have the practice. And there's a lot of feeling of, well, I like to make other people happy. So it's this stressful feeling to participate in an activity that may require you to put the needs of yourself or the group above the other party. But on the flip side, some people do really enjoy negotiating. It can be fun and challenging, especially if it's a topic that you're knowledgeable about or feel strongly about. Sometimes it can be great and people enjoy it. So it was a little bit 50-50 split there. Then we asked, do you feel like you're a good negotiator? A slightly different question, not just whether or not you like it, but do you feel that you're actually good at this? And this was a straight 50-50 split. Again, people who felt that they were good at negotiating kind of had responses where it takes practice, and that when they feel like they're a good negotiator, they've taken the time to understand both sides and come prepared, or that they enjoy, doing the research part and being part of a team, perhaps, that is negotiating on a contract or something where it's more for the company. Some people feel that they're good at certain types of negotiation, like policy, engineering concepts, but a lot of the people on the flip side that said, no, I don't really feel like I'm good at this, it's usually when it stems from negotiating personal needs, especially when it comes to money, salary, that kind of stuff. Some people feel that they settle too quickly, and it's just kind of one of those processes that they're not super comfortable with, understandably. So then we ask the question, would others say that we are good negotiators? So beyond what we think about our own skill sets, would our bosses, our colleagues, our clients say something differently than we feel ourselves? And you can see in these two pie charts that where we had the 50-50 split on do you feel like you're a good negotiator, more people said, yes, I feel like others would say that I'm good at this rather than how I feel about myself. So that tells me we need a little bit of a boost in confidence in these skill sets. Getting quite the delay. I'm sorry for the slow transitions. The next question we asked was kind of one on whether you're more comfortable negotiating for others rather than yourself. And this was a pretty outstanding yes. Most people feel that it's much easier to play up the values and needs of other people rather than themselves. It releases that stigma of self-interest or feeling selfish, especially when you're asking for something that benefits you personally. It's easier to kind of take the emotion out of it when you're not talking about yourself, when you're talking about a team or your company or your coworkers promoting their value. So more people felt like they were comfortable with that rather than talking about themselves. However, there were a small section of people who said, no, I love negotiating for myself. When I have more skin in the game, it puts me in the process better. And that they're more comfortable negotiating for things that are more tangible to them so that they don't feel like the loss of company money or something that's not theirs. So a couple different perspectives on that. So at the core of all of these responses, it seems like a lot of people, when thinking about negotiation, don't really feel comfortable with this perceived conflict. We want to make other people happy, and we want to help others over ourselves. There's a little bit of lack of confidence in our own value and what we bring to the table when we're negotiating. We kind of feel more comfortable to defer to others or perceive their value as higher or more worthy in these types of situations than our own. This whole idea of feeling selfish when the focus is on our personal value or benefit. Striving for equity, fairness, and positive relationships as the marker of a successful outcome is very important to people. And we are more critical of ourselves and struggle to see our value. We find it easier to focus on the needs of others. It's easier to remove those emotional responses when the focus is not purely on us personally and tied to our value. And just trying to please everyone. We want others to be happy, especially our opponents walking away from a negotiation. So we asked our participants in the survey, what qualities do you think make a strong negotiator? And we heard a lot of feedback, things like good listener, that they know the facts and that they can recall them during the conversation. They understand what the other side wants in addition to what their goals are in the negotiation, which can be very important. They know maybe past precedents or similar scenarios that have been negotiated in the past and kind of what works there. They take the time to plan their strategy and develop a BATNA, which is a best alternative to a negotiated agreement, which we'll talk about quite a bit more here. But that's kind of your plan B, right? If the negotiations fail and you don't agree on what you came to the table to agree on, what do you do next? What is plan B? So other strong skills, they communicate their argument clearly and concisely. And emotion is one of those ways to easily erode that, but they avoid apologetic language and the circular speech. Good negotiators use eye contact and confident body language. Strong emotional intelligence can also be very helpful here, where you understand your opponents. You can kind of read people and their facial expressions and their body language and movement as well, and not immediately put people on the defensive. Focusing on facts rather than getting that emotional response. And strong negotiators don't really lay out all their cards on the table right away. We hold some things back to allow the discussion to develop, and then we use those things strategically to keep our argument from stalling out. If you lay everything out on the table right at once and you kind of get that no up front, what do you do next? You'll just end up talking in circles and repeating yourself because that's all you had prepared. So again, that goes back to the BATNA. What else do we have in our arsenal to negotiate with? Then we asked what traits we felt made a weak negotiator. And these, the feedback on this came back to be like poor listener, people who interrupt. They're always focused on the opportunity to talk next, really, rather than really hearing what the other side has to say. They come to the table unprepared, not only in their own argument, but what happens if the negotiation starts to not go the way that they thought. They allow their passion for the subject to come off as desperation, which can lead to being over emotional. You can get frustrated, angry, feel defensive, and God forbid, tears start to roll. When people come to the table and they're closed-minded, they're not willing to come away from their predetermined agenda or the goal that they had set for that negotiation. They don't back down, or excuse me, they do back down. They end up trying to kind of please their opponent rather than really find that win-win outcome. They're poorly informed about their topic or opponent, and they use weak or apologetic language. They talk too much or have kind of that inferior body language pose that puts them on kind of the weaker level. So before we move on a little bit more, I want to talk about what is examples of weak or apologetic language. The way we present ourselves verbally, written communication is so very important, and there are a lot of habits that we come into either culturally or gender specific that really can inhibit our communication. So examples of weak language are using words like I think, I feel, I believe, because it qualifies your statement. Hopefully, just, potentially, possibly, but, saying I'll try, apologizing for things that, you actually didn't do anything wrong or not your fault, but saying sorry all the time will diminish any kind of argument that you're trying to make. We make statements that reduce our credibility from the very get-go. Sitting down at a negotiation table and saying to your opponent, I'm not an expert, but I think, pretty much negates any credibility you have right at the bat. You just said, I'm not an expert, so why should they want to listen to anything you have to say? Ending your sentences in taglines that search for validation. I think this about the situation. Don't you think? Isn't it? These kind of questions come across that you're not confident in this statement you're making. You have to end it in a question to seek that validation. So a note on language here and how we communicate in a little bit of a realm looking at the differences between genders. Females typically in research show that they're more sensitive, better communicators. We catch nuances and recognize body language quickly. And women tend to use more speech that evokes emotion. As humans, we kind of naturally gravitate towards emotion. So it's a little ironic that women tend to use minimizing language far more than men do. It's kind of an unconscious habit, perhaps utilized because women are insecure about sounding too aggressive, too bossy, or even arrogant in these types of situations. So the research shows that when men use speech habits like this, it doesn't really impact how authoritatively they come across. But for women, these habits definitely have a negative consequence in terms of how we are perceived. So finding a way to be direct and assertive is different than being aggressive. And so for women going into negotiation, focusing on your communication skills can be highly, highly important. So let's take a look now at principles of negotiation. So the top 3 bullets on this slide: fairness, seeking mutual benefits, and maintaining the relationship. These are kind of the 3 fundamental principles behind negotiation that are very important for a successful outcome. Nobody wants to play dirty. Everybody wants to seek a mutual benefit to come out of these types of negotiations. And you do want to maintain the relationship with whoever you're trying to negotiate with, especially in personal situations when we're talking about spouses, friends, and family. Of course, we want to maintain those relationships. And then when you bring this into a business realm, clients, bosses, of course, we want to maintain those relationships as well. And coming away with a mutual benefit, everybody will feel good about the process of the negotiation. The bullets further down: attitudes, knowledge, interpersonal skills. Negotiation is strongly influenced by underlying attitudes. The more you know about the issues at hand, the better off you are. Good interpersonal skills are essential for effective negotiations. So again, these are your listening skills, verbal communication skills, being direct, but also being able to build rapport, problem solving. You know, we're here to come to the best win-win type of agreement, decision making, rather than just talking. Let's actually make some decisions and move forward. And this idea of being assertive, but not aggressive, and being able to handle difficult situations, especially when, you know, negotiations start to not go the way that you think they're going to go. So what are the stages of a negotiation? What's the process? There's 5 main stages of negotiation, which start with preparation, then you move into discussion, clarification of goals, then you kind of do the negotiation part where you're working towards that win-win outcome. And that's when you have your plan B or your BATNA in your back pocket. And finally, you're going to either come to agreement or a failure to agree. So if we look at these a little bit closer, stage 1 is preparation. And this is the most important part of negotiation, in my opinion. How we plan for negotiations really sets the stage for how successful you can be in your outcomes. So how we plan, we want to identify what both sides want out of the negotiation and where are your areas to give, not just take. So develop scenarios of how the negotiation can go and your response to the hard questions or when things do not go your way, and know your facts. Know knowledge of the facts of the situation, doing research ahead of time, and really preparing yourself to be able to answer tough questions will give you the best possible outcome. Understanding your opponent and their limitations on what you are asking for, especially in the case of asking for a raise or a promotion, stuff like that. What is your company able to do for you? Are you asking for something that is, you know, not even doable? Or what else can you, give or take for to get something that will be satisfactory to both parties? Write down your points and develop counterpoints and your rebuttals to, try when your opponent kind of shuts down your points. Have a clear goal, what you're looking for out of the negotiation, and then your best alternative if that goal is not going to end up getting agreed upon. And then practice with friends, colleagues, anybody that's willing to play that devil's advocate and play hardball with you, to really practice for those moments where, your throat tightens up and you want to have an emotional response. Practicing for those ahead of time will help you not escalate that situation when you actually have the negotiation. So stages 2, 3, and 4 all happen at the negotiation table. Once you've done your preparation and you practice and you're ready to have your conversation, we start with a discussion. And the discussion is where members of each side put forward their understanding of the situation. This is where key skills of questioning, listening, and clarifying will really help you. The next stage is clarifying goals. So we've had our discussion, we've put it all out there. We present our goals, we present our interests and our viewpoint in each side. So this is where we kind of go back and prioritize. We establish kind of this common ground, minimize the potential for misunderstanding, and clarify exactly what we're trying to get out of the negotiation. Once that's been done, we start negotiating towards that win-win outcome. So once both sides have clearly kind of stated their goals, then we look for the suggestions of alternate solutions, or how can we compromise? How can your goals and my goals come together and we can leave this table feeling like we're on the same page and this is a win-win. So key skills here is really making sure that both sides feel that their side has been taken into consideration. We've looked for possible solutions or compromises outside of maybe just that goal that you came to the table with. And both sides want to walk away feeling that they've gained something positive from this experience. Again, here is very important to have your best alternative to a negotiated agreement. What is plan B? And then after you've completed all these processes at the negotiation table, we either agree or we don't agree. And so what happens if we don't agree? That basically just means we have to revisit the negotiation table again at a later date. Maybe the parties need to go back and do some additional research, come back with more facts, come up with more solutions the next time you sit down. It doesn't have to be a hard no, but it means that at this point in time, it's not going to happen. If you do reach an agreement at the negotiating table, the next step would be to put together a process for implementation. We've agreed upon what is next. How are we going to put that into practice? So to wrap this up and kind of summarize, the most important things we can do is really plan, prepare, and practice our arguments. Know your opponent and what is important to them. Be a good listener and know when and what you can give. It's not all take in a negotiation. We're not here to, if I don't get what I want, and I'm not playing the game. You really have to be able to find that balance of give and take. You want to strategize your pitch and your potential counterpoints from your opponent. Don't lay all your cards out on the table right out of the gate. Save some things to help keep your conversation from stalling out if you're feeling some resistance from your opponent. Stop using the apologetic language. Keep your arguments very clear and concise. Avoid emotion and that passion in your communication. It's good when we feel very strongly about what we're talking about, but when too much passion comes across in our voices, it can easily turn to desperation and the perception that you're starting to get flustered, and circular arguments, repeating yourself over and over again is one of the quickest ways to tank your negotiation process. And then lay out your argument. As Dr. Devin said, it's very important to come in with a structure, not only for a presentation, but for a negotiation argument. And a lot of times in negotiations, it's good to lay out the why first. Why are we here? Then the how, and then finally the what. So for an example of this, if you're coming to the negotiation table with your boss for a raise, we lay out the why. Why are we looking for this? And then the how. How is this going to, come into play? And then finally the what is the raise, right? So setting up your argument in that kind of structure can be really beneficial when coming to the negotiation table. And finally, just recognize the value you bring to the table. Have that confidence by planning, by preparing, by practicing your argument. Have the confidence in yourself to come to that negotiation table. Knowledge and practice will build that confidence, and we really just don't want to let that lack of confidence crater your next negotiation. So with that, that's kind of all I have. I'll turn it back over to our wonderful moderator, and I will be happy to answer any questions if you have some.
Thank you very much, Mr. Jones, for that wonderful presentation. And you put very nicely all the things with a good sample survey. I would like to know one question. I'm looking for some questions from here, but I would like to put some questions to you to start with. What was the sample size of that survey?
I'm sorry, say that again.
The sample size of the survey, you conducted the survey on asking some questions. Are you a good negotiator? Are you a bad negotiator? Or
Right.
what you're negotiating for somebody else? What was the sample size, and what the people in that survey that involved to give that responses?
So the sample size, we had, I believe, about 40 respondents to that sample. We originally gave that survey to the Women in Deep Foundations Committee. That's kind of how the idea of talking about negotiations started. So we started within our own committee, and so most of the respondents to that were female. And we have decided to put the survey out to all of the technical committees for DFI in the United States. That should actually go out within the next week or two, and we're going to get a larger sample size and kind of reanalyze the data, see, you know, if it changes the perception a little bit, and there will be a forthcoming article in DFI magazine, hopefully, on what we learned from the larger survey sample.
Oh, great. So it's work in progress.
It is. It's always a work.
You started off with the Women in Deep Foundation. And as you said rightly in the presentation, women are the best negotiators, and they understand the body language. And I think the flexibility of the woman is so good and so great. That's the reason why they will fit into any profession very well. And that in this part of negotiations. Yeah, I sincerely appreciate that observations of yours. And in the sample size of around 40, what you got so far, and probably you'll be getting some more, definitely the people are comfortable in negotiating for somebody, keeping their selfishness away. So probably that is one thing. But as you rightly said, when you're coming to the table, you recognize that you have to bring something to the table. And there is more in giving rather than taking. Yeah? If you start putting that across, probably we can negotiate better. And if you give that feel of comfort to the person who is giving you, that you are not trying to take away something from him, but you're giving worthy values to him, so naturally you feel more comfortable. But as you nicely put it, you have to plan, prepare, practice your argument well in advance so that you can do. But as you rightly said also, it also depends on the size of negotiation that you're in. If it is voluminously big, or if very big players are there, then definitely the preparation is much more required, and the questions will be coming from various angles, and you should be having that skill to keep your cards at yourself first before putting out all the cards, and spread out those cards. And if you're a team of people negotiating, then managing your own team is also becomes very important, because each person gets excited at different times, and we should not overcommit ourselves in the process. So that's one wonderful thing. And as you said rightly also, we should not be using apologetic language in the process. Yeah, that's one observation, very nice. And as you said rightly in the end, that you should, when you're going to the table, you should have this typical questions to yourself, like why, how, when, what is that happening? And then you should keep your presence of mind very much in negotiation. That's what one thing I noticed. Actually, you should be very, very, you cannot keep dreaming around about something else while you are negotiating, and when the stakes are very, very high. Yeah, so that's a wonderful presentation, madam, and I think no more questions from the people. But I feel we have an NGO in India called Art of Living. So they teach us a lot. I'm not a member of that, where they teach us how to breathe, and generally we breathe shallow and what do you call shallow and hollow breathing. But art of negotiations is something that you have wonderfully put together. I understand there's one question. The question is from Balakumar, who is an excellent practicing geotechnical engineer and a good friend of mine. His question is, how does the negotiation strategy change when there is a color or gender difference? This is something affecting the outcome of any negotiation nowadays. Your views? So he's asking that question, the gender difference that makes a difference in the negotiation process.
Absolutely. So there are some things that you can do to plan and prepare for that, right? It's knowing your opponent. So if you're going to the negotiation table with somebody who's of a different gender, say a woman going to negotiate with her male boss, understanding the differences in how we communicate and our verbal skills and kind of that emotional intelligence piece is going to be your strongest asset when you go to that negotiation table, and vice versa. You know, if you're a male who has a female client, how you deal with her on a, you know, kind of those interpersonal skill levels, and really knowing your opponent and what's important to them is going to help you in that negotiation. So understanding the differences between how genders communicate, or cultural differences if you have you know, if you're working for a foreign company or something like that, differences within your clients can really help you. So it's the preparation stage where you prepare and you do a little bit of research on who you're going to be negotiating with, and then listen when they talk and when they lay out their side of the argument, right? Those good listening skills, take notes, so that may tweak your argument as you go along, right? How you're going to present your information. So those interpersonal skills, especially when dealing with people who are different from us, whether it's gender, cultural backgrounds, anything like that, your interpersonal skills are really going to be your best asset at the negotiation table.
Yeah, thank you very much. That question is basically from Mohan Ramanathan. I misspelled it or understood wrongly from Balakumar. So Mohan Ramanathan is a very active member in DFI India and is a very senior member, a very passionate geotechnical engineer. So as I understand, it is definitely the gender difference will be there. Probably that advantage is to some extent only, but it generally depends on how well or how good a listener you are and how you're keeping your presence of mind well. But definitely, as you said rightly, the gender makes a little difference because the ladies can understand the body language, and being flexible and being sensitive, they will be able to negotiate better. But probably with your sample survey going more and getting some more data, you'll be in a position to explain much better probably in the time to come. And DFI will be deeply benefited with the experience of your survey, yeah, and the data that you collect in the survey. So with that, I think there are no more questions. A wonderful presentation, Mrs. Joel and Mrs. Jewel, sorry, we really thank you for waking up early in the morning and spending your valuable time with us on a difficult subject called negotiations.
Thank you very much for having me.
And you negotiated very well with us in trying to give us that little inputs to prepare very nicely for negotiations, observe the body language, and keep that questions in mind: why, how, when, how we can improve, and go to the table with that an intention, a real good intention to give more than take. With that, you'll be a good negotiator in the end to come out. So with that, thank you very much, madam, once again for your wonderful presentation. And I hope you'll be getting much more data and you'll be able to present to DFI, the whole community of DFI, much better data, and so that we'll all become very good negotiators when you're dealing with our clients. Thank you very much. Then we have some small announcements and the upcoming webinars. This webinar is the third webinar in a series which is started off around 2 months back, where the tagline of this groundwork, that is actually outreach to the students or outreach to the young geotechnical engineers. The tagline is laying the foundation for the next generation of foundation practitioners. So this is a wonderful webinar series. This is the third one that we just completed with the international experts on the webinar. We have one more coming up on 20th April, around a month away from now. As the tentative date is 20th April 2021. And the fifth webinar is the middle of May and tentatively dated as 18th May 2021. Program details and final dates will be communicated to all the participants. Thank you very much for all the things. And there is another upcoming seminar is there, webinar, wherein it is on the organized jointly by DFI India and IGS Delhi chapter on CFA, that is contiguous flight auger files, theory, prospects, and applications in India. And the speakers, the date is just tomorrow at 4:30 to 7 p.m. I request all the participants of today's program, as well as the professionals and students and academicians, to make a good use of this presentation, where the speakers are Dr. J.T. Shahu, professor from IIT Delhi and secretary of IGS Delhi, where he will be talking about the pile foundation, difficulties in alluvial soils, and possible way forward. Mr. Andrews M. Bacuzero, Vice President of Keller North America, will present world-class and world case studies on CFA piles. I'm sure it must be world-class, at the same time world case studies, which will immensely benefit the participants, from a typical project to an extreme application. And third speaker tomorrow will be Dr. Sunil Basarkar, General Manager of Infra, Mumbai, and Chair of DFI India's CFA Pile Technology Implementation Committee. Will present on CFA piles, design approaches, suitability, and applications in Indian use. Registration is free for all this, and the experts are going to exchange their expertise with you. So I request all the participants of today's program to join tomorrow, especially the students, to make best use of the expertise that is going to be available tomorrow on the webinar. I once again thank all the attendees for this program, and I also request them to attend for the next programs. So with that, we come to the conclusion of this program, and I thank DFI management for giving me this opportunity to moderate this webinar, and also profusely thank the speakers of today's evening in India, Dr. Devon and Mrs. Jules, for their excellent presentation and enriching our knowledge in anchors and in negotiation skills. With that, I thank you, and we conclude the program. Thank you, one and all.